So now we can go ahead and jump into the third problem, which is asking us to evaluate the limit as x approaches pi of this whole function right here. So the way we go about this is first by plugging in. When you have a limit, the first thing you want to do when evaluating it is always to plug in what it's approaching. So let's go ahead and do that. We have limit as x approaches pi of cosine of pi plus sine of 2 pi plus 1 over pi squared minus pi squared. We can go ahead and evaluate our trig functions and say limit as x approaches pi. It's going to be cosine of pi is 1, -1 actually, plus sine of 2 pi. Sine of 2 pi is just 0, plus 1 over pi over 2 minus pi over 2. -1 plus 1, 0. Pi over 2 minus pi over 2. Sorry, pi squared minus pi squared, 0 as well. 0 over 0. Um, when both the numerator and the denominator of the limit go to 0, that means that L'Hopital rule applies. So we can write L'Hopital applies. Basically, L'Hopital being the limit as x approaches some y, f prime of x over g prime of x. Essentially, if L'Hopital applies, we are just going to derive the top and the bottom. So we can go ahead and rewrite this new limit as x approaches pi. Derivative of cosine is just going to be negative sine x plus derivative of sine of 2x is going to be 2 cosine 2x. Derivative of 1 is just going to go to 0 over the derivative of x squared. We've seen this previously. Derivative of x squared is just 2x. And derivative of pi over 2, although it may look like a variable, it is actually a number. 3.14159 and so on. So it goes to 0 as well. So this is our new limit right here. Negative sine x plus 2 cosine of 2x over 2x. From here, we can go ahead and plug in again and evaluate the limit. So you can say limit as x approaches pi of negative sine pi plus 2 cosine of 2 pi over 2 pi. Now we said negative sine of pi goes to 0. Now cosine of 2 pi, on the other hand, actually goes to 1. So this can actually be written as 2 times 1. And we just have 2 pi on the denominator. So this is going to be limit of x approaches pi is going to be 2 over 2 pi. Now if we go ahead and simplify this further, it's going to be 1 over pi, giving us answer B. So here for problem number 4, ignore the 2, sorry about that. For problem number 4, we are going to evaluate another limit as its x approaches infinity. So when looking at something like this, or any limit that's approaching infinity, you always want to compare the highest degrees of both the numerator and the denominator. The highest degree of the numerator being 9x to the fourth, and the highest degree of our denominator being 2 from the x squared. So since we are just comparing those two, what we can actually do is rewrite this limit as x approaches infinity of the square root of 9x to the fourth over x squared. Now, this would turn into 3x squared over x squared. Our x squareds cancel out, and it's just basically going to equal 3, giving us answer B.